Alright students, in this video we are going to look at trapezoids and kites. So a trapezoid is a quadrilateral that has one pair of opposite sides that are parallel. So in this example we have trapezoid ADCB, and we know that there's only one pair of opposite sides that are parallel. And that's basically the definition of a trapezoid. The two sides that are parallel, we call them the bases. So we can call this base 1, and we can call this base 2. The two other sides that are not parallel, we call these the legs. Leg 1 and leg 2. In a trapezoid, the two sides that make up the leg, so for example, these two sides, the two legs, again they're called the legs, the two angles that they're making, for example, angle A and angle B, angle A and angle B are supplementary. That means that both of those angles add up to 180 degrees. The same can be said about angle D and angle C. They both add up to 180 degrees. So that's the simplest definition of a trapezoid. It's a quadrilateral that has exactly one pair of opposite parallel sides. When we analyze what an isosceles trapezoid is, so isosceles trapezoid. So let's see if we can copy this trapezoid up here. Let's just make a new one. So let's say we have something like this. So if these two are parallel, we know it's a trapezoid. But if the two legs are congruent, then we say this is a trapezoid. So a couple things about an isosceles trapezoid is that the base angles will always be the same, congruent. So we have two base angles because this is the base. Here's base, base 2, and base 1, so we call these the base angles. And those two angles will always be congruent. Also, in an isosceles trapezoid, the diagonals will be congruent. Diagonals will be congruent. So if I have this diagonal, that will be congruent to this diagonal. Okay. We can also say that, well, we can also say that both angles, because it's a trapezoid, we can say that both of those angles are supplementary as well, just like we had up here with a regular trapezoid. So that's pretty much the description of what an isosceles trapezoid is. Remember, a trapezoid is still a quadrilateral, so all the angles added together add up to 360 degrees. Alright, so that's a trapezoid. And actually there's one more thing I would like to cover with regard to trapezoids. Let me just clear this up a little bit. And so let's do what we call the mid-segment of a trapezoid. So let's call this trapezoid, let's call this trapezoid ABC, A, B, C, D. So the mid segment segment of a trapezoid is basically a segment that is in the middle of the two bases. So for example, this is a mid-segment because it's in the middle of these two bases. And we know that if that's the middle, then these two segments must be congruent, these two segments must be congruent. And basically the way you find the mid-segment is when you take the average of the two bases. So let's say this base here is 10, this base here is 20. Well, we take the average of the two, 10 plus 20 is 30 divided by 2, and we get 15. So that's how you find the length of the mid-segment. All right, the next quadrilateral that we are going to look at is what we call a kite. And basically a kite is a quadrilateral that has, unlike the trapezoid, it has two distinct adjacent and congruent sides. So in this case we have trapezoid CDAB, and as you can see, the two adjacent sides are congruent. That's why we say two distinct. Distinct really means different, unique adjacent sides. So CD congruent to CB, BA congruent to DA. In a kite, we can also say that there's only one pair of opposite and congruent angles. So we have angle C is congruent to angle A, or we can say angle B is congruent to angle D, but not both. So it's either one or the other. Additionally, we can also say that in a kite, the diagonals are perpendicular. So that means that CA and BD are perpendicular, so which means this angle here is 90 degrees. All of these angles are 90 degrees, and so forth. Additionally, since we're talking about diagonals, we can say that the longer diagonals, or the longer diagonal bisects the smaller one, or the shorter diagonal. So what that means is that CD bisects BD. That means this is congruent to this segment here. And if you pay attention, what we have here is 4 right triangles. So keep that in mind when looking for a missing measure, that hey, this is 90 degrees. You may have to use the Pythagorean theorem, a squared plus b squared equals c squared. So keep that in mind. Please let me know if you have any questions. Go back and watch the video again, or just send me an email with any questions that you may have. Thank you. Have a great day.